So good evening, everyone. So here we are again, our Uncaught section mini sessions. So in these sessions, we try to share new texts or some text that we used or discovered over the past week and talk it about here. So for tonight, our first share speaker is Arnelle Balane as usual. Come on.
Hello. I'm going to remove everyone from the stream. Hello, everyone. So what I would like to share about is about lazy loading on the web. So as we might know, images constitute like a huge portion of like the sizes of our web pages because they images can take up a lot of size. For example, I have a sample image here. This is 139 kilobytes. So traditionally, by default, when you include images on your web page, they get loaded right away, even though they're not visible on the screen yet, as you see here. So if I reload this page, you see there's no image yet, but the image was already downloaded by the browser. So this can have impacts on performance because downloading the images can take up like bandwidth that could have been better used for other more important resources. So one way we can improve this is by lazy loading our images or only loading them when they are about to be displayed on the screen. So how do we do that? So in the web, there's now a native support for lazy loading images. All we need to do is add loading lazy to our image tags. And what that will do is the next time I refresh this page, for example, you see the image in the tools is not loaded anymore. And as I scroll down the page, as I read like the content, for example, it will only get loaded when it's going to be displayed. So in this case, in Chrome, or it depends on the browser when they will lazy load it. So different browsers might do it differently. Last time I checked in Chrome, it's somewhere, I'm not sure about the number anymore, but somewhere around 2000 pixels. So if the image is 2000 pixels away from getting displayed, then that's when Chrome will um, load the image. So you might want to check that number again. Uh, yes, so that's native lazy loading using loading was lazy. So there's also auto where you just tell the browser to decide if it wants to lazy load or not. And also the opposite of lazy is eager. So if you really want to load the image right away without or aka not lazy load it, then use loading eager. So that's lazy loading. Um, we look at and I use that the browser support. It's as you see, it's not very supported yet. Started with Chrome and then now with Edge because Edge is now using like Chromium underneath Opera. So how do we do it for like other browsers that would support it? So um, for those browsers that don't support native lazy loading, what we can do is we can use a third party like a JavaScript based lazy loading library. So my favorite one of them is Lazy Sizes because it's very easy to use. So there are many ways to use it. You can download the JavaScript file, oops, sorry, or you can install from npm if you're using like npm packages already. So let's see how we use it. So in my case, for this example, I downloaded the JavaScript file, and all I need to do is load that file, and then because loading is not supported in this case, I'm just going to remove it so that we don't get distracted. All we need to do is add a class of lazy load. I think that's the class. And what we'll do is lazy sizes will by default find all the images with the lazy load class and then lazy load them. So let's see, I refresh it. Oh no. Okay, that's not enough. So another thing, because by default, image SRCs will automatically get downloaded by the browser. So if you are using lazy loading libraries, we need to change the SRCs to data SRC so that the image don't get automatically loaded. And it will be up to the lazy loading library to change this to SRC or something like that. So it again, refresh. As you see, the image is not loaded. Lazy sizes or whatever lazy loading library you're using is downloaded. And as I scroll, um, see that it only gets loaded when it's about to be displayed. So nice thing with lazy sizes or using lazy loading libraries is you can configure certain properties. For example, how far do you want it to, like what's the threshold for that it will use to, like, when it will lazy load. And in lazy sizes, that's called, actually I don't remember what it's called in lazy sizes. I think it's called threshold. It's a data attribute that I don't remember. Uh, anyway, so you can do things like that. So instead of the default, like in Chrome, which is around 2000, and you can control, like, only show it when it's really about to be displayed, let's say zero offset or something like that. So that's it. Uh, the native lazy loading, or like lazy loading, plus lazy, also works for responsive images. So if you are using like SRC set, for example, which we want to really show now, to display like different resolution images based on like the size of your screen, or if you are using like a picture element, so so loading lazy will work for both of these. And the same way with lazy sizes. Lazy sizes also supports responsive images. Okay, so those are two things, the native one, and for those browsers that don't support them, we use a third-party library. And how do we combine the two? So combine the two, uh, we have to write some custom JavaScript code. So we can basically feature detect if native lazy loading is supported by checking HTML image element type. So here the name of the property is loading. So you just need to check if loading is available. If it is, and we need to do this ourselves, where we set SRC to the value of data SRC. So how do we do that? Let's just find all the images. This is a hit and dirty query select all. So I'm just going to find all the images and then look to each of them and then set the SRC to do the data SRC and data attribute. So what this will do is, if native lazy loading supported, it will just change this to this something, and automatically lazy loading will kick in and only load your image when it's about to be displayed. However, if native lazy loading is not supported, we need to fall back to our library. So so we don't need to load this anymore. We will just dynamically import it, because if lazy loading is supported, we don't really need to load. Um, we don't really need to load like our fallback lazy loading library, right? So what we can do is we can just use dynamic import, and let's say lazy sizes images. So this is a kind of new thing. This PS modules dynamic imports, which is now supported on the web. So we won't talk about how to, like, feature detect this. So if this is supported, you can do like the type module or no module pattern. But we won't talk about that now. But what this will do is it will only load the lazy sizes script when native lazy loading is not supported. and it will automatically kick in and find all the lazy load classes and then lazy load them. Let's see if that works. I refresh. As we see, because Chrome supports native lazy loading, it didn't load lazy sizes. And if I scroll down, oh no, it didn't work. I think I have a legal invocation. I think it only works in type module. Maybe I'm just making things up. Illegal invocation. It's my illegal invocation. I found this up. Oh no, what is happening? For XML image map. Da, 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 da. Oh, yeah. I checked it the wrong way. It should be loading an HTML image element that. Sorry, wrong picture detected. Um, so let's try this and no error. Let's check the network. So you see lazy sizes is not being loaded, and the photo was natively lazy loaded. Let's try in Safari. Safari, you can load now. Okay, Safari is here. Um, tools in Safari. Let's see. So you see, because Safari doesn't support native lazy loading yet, it's loading our fallback lazy loading library, and as we scroll, it will still work. So this is basically how we do lazy loading of images on the web. So again, also another thing, this native lazy loading works for again responsive images and also for iframes. So videos, not yet for now, but it might come in the future. And that's it for me. Thank you. Yeah, I met a 10 minute thing. Do you have any
Wow,
questions?
that's the first 10 minute mark. Any questions? Time for questions. Q&A section of the mini session. Any questions? I don't have any in my part.
Um, uh, do you have like an idea on like the adoption of this new property uh, with respect to like other libraries that already um, other like libraries, the UI libraries, like for example, those libraries that does React, like React component, so that you don't actually type in the img tag anymore. The component that they have there already defines the img element, and then you likely will not be able to say that a lazy loading. I want to use lazy loading. Do you know like if it's already widely adopted now
Yes,
or
good question. I have no idea. um, but okay, I don't know like exactly if it's supported, but if I'm going to like based on like those libraries that I've used in the past, some of them, especially like the view ones, I think, um, they just most of them just wrap the image component or like image element, right? And then some of them just receive whatever corporate props they receive. They like do like a pass through or like transparently applies them to the image tag directly. For example, in Vue, that could be done using um, vbind of $APPRs, for example. So that they don't really need to like specify every single property. It will just take whatever is passed. It will also apply to the IMG tag. So if those libraries are using something similar to that when they wrap the image tag, I think they should work automatically already. But I'm not sure which libraries do that. And for those who don't, then it might not be supported. But Again, there's loading equals auto, right, which is the default value. So it will be up to the browser also to do lazy loading if it sees it's necessary to do lazy loading.
Okay. Yeah, that answers my question.
So, any more questions? So, I think that's it for Arnel.
Yes, thank you.
So, let's now move forward to the next presenter or sharer or speaker, which who is Eman Lodovice.
Uh, all right.
It's
Hi
your turn.
everyone. Hi everyone. So this night, I will be sharing about packaging your Python project so that it is going to be reusable, or basically making it so that your Python code could be pip installed in simpler terms. So okay, in this um, project, in this demo, I have like two projects. Uh, so sample package and sample project. So I have this file called Koti, which supposedly will just get you like a random code, a code of the day. But the API that I looked at has a 10 request per hour limit, so I've used it up already. But I've created a sample endpoint that returns a similar response here in using our endpoints project. So if you're looking for um, a tool wherein you can just generate a random URL and you specify the actual response object, you can use endpoints for that. Okay, so we have a Python file here that has a code method, and then it will just send a request to this URL that responds this specific JSON with like codes information, and then I get the JSON and then I return it. So we can run this, I think. Let's see. Alright, so it gets the JSON. Then what I want to do is I want to use this code in another project called sample project. And here I have a file called Coder. Or called coding. Uh, so let's see if this runs. Okay, I think I will remove it first. Okay, so right now, okay, code is not there. So right now, I'll just remove the entire virtual end. Sorry about this. Okay. So it doesn't run because Koti is not available in this project. So um, we want this Koti to be like it ideally is like a reusable, useful piece of code that we want to use in multiple projects. So we want to be able to quick install this. So how do we do that? This is very well documented in Python.org for packaging. So simple project. So typically you will have your folder, in this case for PKG, and then inside that folder you will have a Python module. And then inside the Python module you have the init.py indicated as a Python module, and then your Python code should be somewhere within this folder. So let's do that. And like kids. Uh, E, just cut this, and so this I'll just rename to make that pie because it's simpler that way. No extra magic. This is so annoying. Okay, so first step is done. And then a typical Python package will have these files. So first you have your license, so people know if they can actually use your package without being sued. And then README that explains what the package is about, your actual code, a setup.py, and tests. So we'll not do the test, but we'll do the rest. So we will have so your README that explains your useful project, and then your test, just keeping that license. So we'll go down, we'll just copy the license. So this is the MIT license. Let's add this here. Okay. Cool. So we have a license, we have a README. And then the most important thing about this whole step is your setup.py. So the setup.py basically explains or defines the project, what it is, the version, who are the author, what it does, how to install it, and what are the requirements for installing this package. So we can just copy paste this whole entire thing so that we can finish this within 15 minutes. Okay, so typically you will have like you open you read your readme file and store it in a variable, and then your name, of course, we'll replace it. Here, this is not needed. So key and then your version. Okay, let's just keep it as this. Then I wrote this. Email, description, long description. Of course, it's a markdown because it's an MD file. Right now, I don't have a URL, so I'll just probably just skip that. And then setup tools that packages equals setup tools that find package. What this means is that we allow setup tools to like read the directory and identify where our actual code is. So it will just know that code is our package. And then classifiers. So as we scroll to the documentation, classifiers are basically just stuff that more like meta information about the project. Where is it? Where is it? Where is it? Here. So just some meta information about the project. We'll keep it as is because this is true. We require Python 3. We're using MIT license and it is OS independent indeed. For this one, we change it to Python 3.0 because we are not doing anything special in our Koti application. But there's one thing that we need to change. Called install requires because this project uses requests. So a request is not part of the standard library. It has to be installed. So we'll just say request here. And then a good way to see what version of request you are using when you are testing, you can just run to freeze. And then I have request 4. So I'll just put that here and then copy it and alright, let's just say greater than to support future releases. So our setup.py is pretty much complete. It's not perfect, but this should work. Um, then we will do the next step that the tutorial says, which is the part where, um, okay, so let's just do this first. Install upgrade setup tools and the wheel package so that we can generate the wheel file. Okay, it's a good. And then we run this code so that we generate the distributable files. So Python setup.py as this and p dist wheel. So with dist wheel, what we're saying is that we want to generate the wheel file for our package. So a bunch of new files will be generated. You notice you have your build folder and this folder and then some egg. What you're particularly interested in this case is the dist folder because this will contain your wheel file. So the wheel file you can copy and install on other projects that you want. If you don't want to upload this to PyPy, if you want to upload this to PyPy, then no need to copy. You can just click install right away using the package name. But we are not uploading this to PyPy, so let's just copy it and then paste it here uh, in our project, sample project, switching terminals. So here we have Koti. We, we don't have anything installed, so we can just pip install P. So we pip installed the wheel file. Down to freeze again, and then we can see that Koti is actually installed. And of course, request and the dependencies that request requires for it to work is also installed. So now we can run and it works. Pretty cool, huh? So that's it. You are now you've built a Python package that you can distribute and share to your friends. But in real world, that this is not the end. Typically, when you build like a Python project or a Python package, you're building it because um, there's another project that uses it. So, for example, in your company, you are building reusable project packages because it solves a common problem um, between multiple clients. So maybe this could be like, I don't know, a Python package that um, deploys automatically to S3 that you can just pip install, who knows. So it's a proprietary project, and you happen to be one of the maintainer of the project, and you are developing what you happen to be the maintainer of the package, and you are developing one of the projects that uses the package. So the project that uses the package requires a new feature on the package. So you want to add the feature, but how will you do it? They are in different workspaces, and then obviously you can change code here. Maybe you want to add a new print 1 2 3, but then in your other project uh, the print is not there. So to make it fast, you want it so that whenever you change this, it will be reflected in your project. So how do we do that? So we use the power of pip to enable this. So here we first pip and install cookie. Yes, I am sure. We run the project again. Okay, it's not running anymore, but we will install it in a different way. So pip supports installing packages through a directory. So it supports using version control. Like you can pip install using Git URL, whatever. But since this is not in Git, it's in our file system, so we can just pip install it from our file system and paste it. And then fingers crossed, this should work. Okay, so Koti is installed. You can run to freeze again. Okay, Koti is back in the game. Run the project. Okay, it's running fine. So now let's see if we print this, save it, when we run again, do we see the print statement? No, not working as intended. You pip uninstall and try a different method. Yes. So okay, what's not there anymore? So that happens because when we pip installed the directory, um, we didn't mark it like in dev mode. So to mark it in dev mode, we use a -e flag, meaning it's editable. Then we install -e, uh, run coder, so we have test. What if we change it to test what edited? See test what edited is reflected. So that is the most simple way you could set up so that while you are building the package, you're able to make changes on the package and it will already be reflected on the projects using the package right away without doing all the building, copy pasting of wheel, etc. So I guess that is it for me. If you have any questions, let me know.
All right, thank you for that, Eman. So, yeah, the second Q&A portion for tonight. Any questions, guys?
Yes, I have a question. So the wheel file that you built, is it some format already that gets uploaded to registries like PyPy or others?
I think the wheel is now the standard way of distributing Python packages. It replaces the former egg. So I think, yeah, I think PyPy does. If you upload it, I think I haven't done it, but I think if you uploaded the wheel, it will choose the wheel. But if you did not, then it will choose the archive, which is the other one, and in the build folder, the tar.gz file, which actually contains your actual code.
I see. Okay, thank you.
I also have a question. So, when
Yes.
you flag the file with E, like editable, does that mean that the wheel file, when you update the source package file, like when you added the print test, the wheel file also gets updated?
I don't think so. Like if you install the wheel, you won't be able to do the -e if you install the
Okay.
wheel file because the wheel file is already like the build distribution. You won't be able to edit
Okay.
that. I think what the -e does is like it sort of um, adds the project into your side packages and in your project, adds the package into the side packages of your project. In a way, maybe like a soft link. I don't really know exactly how it works. So basically, it's just that the Python in your project, the interpreter, sees your package folder as one of the dependencies. It's not, yeah.
Okay, all right.
Some
Thanks.
shenanigans there.
Any other question, guys? Or else we're gonna end it right here.
Okay, now
So yeah,
since we had
It's less than
13 minutes
1 hour.
session.
for the first time we ended at 30 minutes. So yeah, I think that's it for tonight. So Arnell shared about the what lazy loading, and then Eman shares about the making reusable packages for Python projects. So for next week, I think we can expect RJ to present a new member. Woo! So that's it for
Hallelujah.
tonight, guys. Thank you for watching and participating. I hope you come back next week. And yeah, for those who's watching this, don't forget to like and subscribe. And if you want to present, maybe you can just slide to our DMs. Bye bye.
Thank
Bye
you.
bye.